Okay, in class last week, we talked about displaying quantitative data. Started off talking about that with pulse rates from our class data, and I talked about how to make a histogram. So, just as a very quick review, remember first you start with a frequency table. So, I chose my bin widths, how I wanted to set this up, made my tally chart by going through my data, did my counts. Then I went ahead and graphed that. You want to make sure you include scales always. And when we talk about a distribution, we're always looking at center, shape, spread, and unusual observations. So you always want to make sure you address those. So we talked about, when talking about shape, our data was approximately symmetrical, but remember you can also have skewed data. If it's skewed to the right, would be this first example. It always goes skewed to the tail. So skewed to the right means the tail is to the right. Skewed to the left means the tail is to the left. The plot I want to talk about now is called a stem plot. Sometimes it's referred to as a stem and leaf plot. So when you have a stem plot, the first thing you have to decide is what's your stem going to be. It can only be single digits. So, and your leaf can only be single digits. So for ours, since we had some in the 50s, some in the 60s, 70s, 80s, and 90s, those will be our stems. And then we draw a line, and then we're going to put our leaves on this other side. So you'd go through your set of data. So the first one on our set is a 74. So I'm going to place a 4 here. And then we had a 72, and then a 77, and then a 66, a 76, 67, 70. I paused it and then just did the rest so I wouldn't bore you. So we end up with our stem plot. Now, these over here are all considered the leaves. But in order for this to really be helpful to us, I mean, it's helpful as far as our distribution. As a matter of fact, if you look at your histogram and you notice the comparison, if we turned this sideways, it would look like this. Or if we turned this sideways, it would look like the histogram. However, to be more useful, we really need to have the leaves in order. So you would recopy the stem and put all the leaves in order. So there they are in order. And the last thing you would do is include a key that might look something like this. 5-1 means 51 beats per minute. So that's the key. Now that's important to have because sometimes your stem could be the ones place and maybe your data has tenths place. Maybe it's decimal data. So 5/1 could be 5.1 centimeters or something, whatever your data set represented. So this again is a stem plot or sometimes called a stem and leaf plot. Now it's very much like a histogram as far as the shape, but I like this because I can still see the data. So remember with a histogram, we lose like what the actual data is in the 70s column, but here we retain that. So that is helpful. However, for large data sets, this was a little awkward to do this for my stem plot where the histogram was a little easier for large data sets. So sometimes you want to compare two sets of data, and you can actually do any of these plots. You can do a histogram or a stem plot where you, in this case, I'm going to split this. Actually, I'm not going to split the stem, sorry. That would be something else I would do. So let me backtrack on this. We're going to do a back-to-back stem plot. We do a split stem plot, and I'll show you that later, but right now I wanted to do this one. So I'm going to take my 5, 6, 7, 8, 9, and this time I'm going to have two different directions. I'm going to have males on one side and females on the other side. So I'm going to have to kind of, let me pause this. Okay, I just folded my data sheet so I could see the gender right next to the pulse rates. So the first one on our list is male and 74, so I'm going to put a 4 going on this side because it's the side that represents the male. Next is a female 72, so I'll put the 2 on this side. Female 77, I'll put a 7 here. Female 66, 76, female 67, female 70. So here is my back-to-back stem plot. What this allows us to do, and I would need to put a key also on this, and you don't have to show both sides, but I might have, 5-7 means 57 beats per minute. And as with the other, as I said before, you would want to put the leaves in order. I'm not going to take time to do that, but I am going to say the smallest leaf is closest to the stem, which makes sense going to the right, but to the left it's going to seem backwards. So actually, other than like this 8 would be a 4, 4, 4, 6. So the closer, the zeros are going to be the closest to the stem when you are doing a stem, any kind of stem plot. But you would definitely want to put those in order. Then you can compare distribution. So you could talk about center shape and spread for the females, and you can talk about center shape and spread for the males, and you could look at possible differences. Were there any unusual observations? So that is a back-to-back stem plot. So now I'm going to talk about a split stem plot. Wouldn't do that with pulse data, but I'm going to do that with the number of states visited. So if you take a look at that data, the first person, now what I have here, notice I have 2 zeros, 2 1s, 2 2s, because I'm going to split up the values. So the zeros represent my 0 through 9. So the 0 for my digits, 0 through 4 would go on the first leaf, and 5 through 9 would go on the next one. Same for the 1s. So 10 through 14 would be represented here. 15 through 19 would be represented here. So a 13 would go on this spot. A 19 would go, the 9 would go on this spot. 7 would go here. 10, 15 goes here, because remember this is 10 to 14. 9 would be here. 27 would go on the second 2. 8 would be here. 18, 22. So this is what I get when I'm done. So these are our number of states visited. And so if we were going to describe this, actually I'm going to pause and put it in order because it's going to be easier to describe the center. Well, that's okay. We would put this in order. You might have 0-3 means 3 states. But again, to be technically correct, I have such a large data set, though. I'm not going to do it right here. But you would put all the stems or all the leaves in order. So when you talk about center, I'm going to just say it looks to me like the balance point would be somewhere in the 10 to 14. So between 10 to 14 states. Shape. Now we definitely have an outlier, this 40 states. Now notice that it would be approximately symmetric, except for this. Although it does seem a little skewed to the higher numbers. So I'm going to say skewed to the higher numbers. Now this would be like saying skewed to the right. But it doesn't really have a right. And notice if I tip my head sideways, you would kind of see, or if I made a histogram, you would see it was skewed kind of to the right. So if you're not sure, like if you said skewed to the right, that would be okay. But if you're not sure on that, you can always say skewed to either the higher numbers or lower numbers. So center, shape, spread. So our spread goes from 3 to 40 states. Again, notice here we actually have the data. And then unusual observations, 40 appears to be an outlier. So that's how you do a split stem. So that was actually all I wanted to cover, just to talk about stem plots and back-to-back stem plots and split stem plots. So I know that some of the problems that you'll start on before I'm back, you'll be working with those types of plots.